So this problem asks you to find the exact value of cosine of 255 degrees. Again, typically, if I ask you to find the exact value, this means without a calculator, so it means we should be able to be able to use special unit circle angles. But if you study the unit circle, if you know the unit circle angles, 255 degrees is not one of them. Oh no, this is a hard question. Well, if I ask you to find an exact value and the angle I give you is not special, it usually means you're going to have to use the sums and difference identities or the double or half angle formula. So you're going to have to somehow alter or do arithmetic with the special angles to get 255. So again, this was a multiple choice question. So depending on the pathway that you take, your final answer may look different than the choices offered. Whatever pathway you take, you just have to make sure that once you get your answer, that it matches with one of the choices. And if it doesn't match, you just have to do a little bit of arithmetic to guess to check. So 255. Anytime I work with really big angles, I like to see if reference angles work. If reference angles do work, that usually means sums and differences is the way to go. If reference angles do not work, that usually means you have to use the double angle or the half angle formula. So let's see if reference angles works. Sometimes they do not. So cosine of 255 degrees, the reference angle is what? I think that is closer to 180. So if you subtract 180, that's the 75. 255 degrees is in the third quadrant, and I know cosine is negative in the third quadrant. In the degree system, I know the special angles are 30, 45, and 60. And hey, what do you know? I know that if you add 30 and 45, it gives me 75. So it looks like I can go ahead and use the sums and difference identities. All right. So notice how we were able to rewrite the problem as cosine of something plus something. Now, I mean, it'd be nice if you memorized it, but I let you use a reference sheet. So you had these identities for you guys to use on the exam, and just follow the pattern. That's it. You did the hard work. Everything, this right here is the hard work, right? The rest is just figuring out what the pattern is, following the pattern. So we have cosine of something plus something, which is this pattern here. Notice we have this extra negative hanging out in front, so I'm going to keep that negative out for right now and just follow the pattern. So according to the pattern, it's cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. And since these are special unit circle angles, we can actually figure it out. So cosine of 30 degrees is radical 3 over 2. Cosine of 45 degrees is 1 over radical 2, which rationalizes to radical 2 over 2. Minus sine of 30 degrees is 1/2. Sine of 45 degrees is rad 2 over 2. So that equals negative rad 6 over 4 minus rad 2 over 4. Since they have the same denominator, you can make it as one fraction. So the answer was negative radical 6 minus radical 2 all over 4. Now, since it was multiple choice, I forget exactly what the answer was. I can't remember if they left the negative out in front or if they distributed the negative in. So if they distributed the negative in, it would have been negative radical 6 plus radical 2 all over 4, which can then be rewritten as radical 2 minus rad 6 all over 4. So I can't remember if this was an option or if that was an option, but they're all equivalent. And this is what I mean. If you do it one way and you don't see your answer matching, you might have to do a little bit of arithmetic to get it to match. But that's it. If I ask you to find the exact value and the angle is not special, it's going to be sums and differences or doubles or half angles, depending on how you work it. So that was the solution.